Hey guys, welcome to the 8th video in this Flame game development series where we are making Ski Master, a top-down vertical scroller about skiing. In the last video, we added some checkpoints in level 2 and using these checkpoints, we were able to safely respawn the player when it goes off trail. So in this video, we are going to add some snow ramps and allow the player to jump off of them. I'll also implement a simple fade effect at the start and end of each level. So just like previous video, this time too I've already made some changes to save some time. The first one is package upgrade. I've upgraded Flame to version 1.13.1 and Flame Tile to version 1.18.2. Then in the level 2 map, I've placed these flags at every checkpoint. This will help the player to visually see the checkpoints. Note that the checkpoint flags are different than the trail start and end flags. Another change that I've made to all the existing levels is the addition of some extra trail before the start and end of the actual trail. This was done to avoid showing completely empty area when the camera is near the start or end of the trail. I've also created level 3 without the extra trail so that I can show how existing maps can be modified without losing any changes. Okay, so to add the extra trail, we'll have to resize this map. This can be done using the resize map option under the map menu. On this dialog, we can set the new width and height of this map. In our case, we just need to increase the height of the map. Now, instead of randomly increasing this value, I'll increase it based on the number of tiles the camera can see along its height at any given time. Calculating this is very simple. If you remember, we have set the fixed height of the camera as 180 and each tile in the map is a 16 by 16 square. This means at any given point in time, the camera can only see 12 tiles at max along its height. So I'll increase the height of the map by 24 tiles so that we get 12 rows of extra tiles at both the ends. And I'll also change the Y offset to 12 here so that all the existing map setup gets shifted downwards by 12 tiles. And once you hit OK, you should see some extra tiles like this. Now I'll quickly just extend the path and environment tiles to fill this empty area. Notice that I'm not extending the trail hitboxes because from a gameplay perspective, these extra areas will always be non-playable. Next, I'll move out the player start so that the player gets spawned a little outside the playable area. And similar to the trail end, I'll add a trail start trigger as well. Class type for this trigger will be start. Once all this is done, make sure to export the map. Okay, now back in the code, I want to block all the inputs to the player character while it is outside the trail start and end. So first, in the handle triggers method of gameplay class, I'll add a case for the start trigger by duplicating the code for end trigger. For the onCollision start callback of this trigger, I'll create a new private method called onTrailStart. Next, to block the inputs, let's go to the input class and introduce a new boolean member called active with its default value as false. Then in the update method, I want the left input and right input values to increase to their max value only if active is true. So along with the button press, I'll also check for the state of active here. This means if active is false, both left and right inputs will gradually move towards 0 even if the buttons are pressed. Next, in the onKey method, I'll add a check for the state of active before processing the key callbacks. Now back in the onTrailStart method of gameplay class, we can set input.active to true. And exactly opposite to this, we can set it to false in onTrailEnd. Hey, just a quick note from future version of me. I noticed that we could have also updated the last position in the onTrailStart method. I'll make that change in the GitHub version. Next, in the update method of this class, we had added code to update the reset timer when the player goes off trail. With the current setup, is off trail will be true at the start until the player enters into the trail for the first time. But that is not what we want. We want this code to kick in only after the trail has actually begun. So to do that, along with is off trail, I'll also check for the value of input.active. Since this will be true only while the player is in between trail start and trail end, this should be perfect here. Let's run this and see if it works. Okay, So you can't see this, but I'm pressing the keys and the player is still moving straight. And as soon as I entered the trail start, the player started turning. And the same behavior can be seen when the trail has ended. Next, let's add a simple fade in and fade out effect on level start and end. For that, I'll add a late final rectangle component here called fader. The idea is to make it cover the entire viewport and then control its opacity to create the fade effect. So in the onload method, after everything has been set up, I'll initialize fader with a rectangle component with its size as big as the virtual size of the viewport of our camera. This is essentially the fixed resolution size that we had specified while creating the camera. Next, I'll set a new paint for this component with its color same as the background color of the game. To make the level fade in, we'll have to make this component fade out. So I'll add a fade out opacity effect with a linear effect controller that lasts 1.5 seconds as child of this component. This fader component will have to be added to the viewport of the camera so that it stays static with respect to the viewport. And finally, to make the level fade out when the level is completed, we'll have to make the fader component fade in. So in the onTrailEnd method, I'll add a fade in opacity effect to the fader component. Now let's test this in the game. And as you saw, the level slowly faded in when it started. And similarly, it fades out when the level completes. Also, starting the next level now creates this nice fade transition. Okay, now let's start implementing the ramps. So if I go to tiled, you can see that in level 3, I've already placed some ramps with the ramp triggers. And just to explain the setup, I'll place a new ramp near the start. So to mark the visual part of the ramp, I'll switch to the decoration layer and place the ramp tiles. Next, to mark the trigger area for this ramp, I'll switch to the trigger layer and place a rectangle. Class type for this trigger will be ramp. And notice that I'm intentionally making the trigger smaller than the visual size of the ramp. This is done to avoid triggering unwanted jumps when the player is barely touching the ramp. Now back in the handle triggers method, I'll add a new case for ramp triggers by duplicating the code for checkpoint triggers. And for the on collision start callback, let's create a new private method called onRamp. From this method, I'll call a new method on player called jump. Now let's implement this jump method in player class. So since this is a 2D top-down game, we can't really make the player physically jump. But to create the illusion of jump, we can gradually increase and decrease the character scale. So in this jump method, I'll add a scale effect to the body component using the scaleEffect.by constructor. I'll make it scale uniformly until the scale becomes 1.2 times the original scale. For the controller, I'll set the duration as zero point 0.8 seconds. And since we also want the scale to return to its original value after reaching the target value, we'll have to set alternate as true. I'll also set the curve to an ease in out curve. Now let's test this in the game. Yep, and as you can see, the player does scale when it hits the ramp, creating the jump effect. Now, although this works, you'll notice that the jump does not really depend on the speed of the player. This means even if the player's speed is very slow, the jump effect will still look the same. So to make it a bit more dynamic, we can make the scale and duration of the jump dependent on the current speed of the player. I'll do that by first finding the ratio of current speed and max speed. This value will always be between 0 and 1. Next, I'll use this factor to interpolate between the minimum and maximum value of scale and duration of the jump. And then these interpolated values can be used in the scale effect. Now, even if I touch this, it probably won't look much different than before. But if you manage to hit the ramp at a really low speed, you'll immediately notice the difference. Now, just for fun, I'd also like to make the camera zoom in and zoom out when the player jumps. So first, I'll change the return type of this method to double and return the jump factor. Then back in the onRamp method of gameplay class, I'll use the returned value to control the camera zoom similar to how we did it in the jump method. Okay, so to actually change the camera zoom, we can modify its zoom property directly. But since we want to do it gradually over time, I'll instead add a scale effect to the viewfinder of the camera. I find it easier to do it this way, and it also makes the setup very similar to how we did it in the player's jump method. We can literally just copy over the whole scale effect code here. I'll just reduce the max scale to 1.08 since 1.2 is too much for the camera. Now let's try this in the game and see if it works. Okay, and as you can see, it does make the camera zoom in and zoom out when the player jumps. Since this is just an additional effect, it is totally up to you to decide if you want to have this in your version. So feel free to remove it if you don't like it, but I'll most probably keep it. So yeah, that was it for this video. I hope you enjoyed it and learned something new. If you did, do hit that like button, make sure to subscribe to show your support, and I'll see you in the next one.